if a customer that's just starting to think about electrification in, let's say, 2030, and if they apply it for themselves, if things are going carry on like they are, it might be 2040 by the time they can actually get a connection. If they come to us, we're building capacity ready to take them.
Hello and welcome back to the Hypercube Podcast. I'm joined today by Mikey Clark, who is CEO of Relode. Mikey, thank you for joining us today. Would you like to just introduce yourself, Relode, and what you've been up to for the audience?
Yeah, absolutely. Thank you ever so much for having me. I've been an avid watcher of the podcast, so it's wonderful to be invited on. So, as you mentioned, I'm Mikey Clark. I'm CEO of Relode. We are a land and power developer, we hope with a USP in the UK, where we're building out what we think are some of the largest connections onto the transmission system. And we have our whole mandate is really focused on new types of load that are going to be coming onto the UK system over the next 5 or 10 years. So it's a different concept where we're having multiple different types of customers coming onto our own, probably high voltage network. And yeah, really excited to see what we can do with a slight kind of twist on what is the norm at the moment.
I think, and that's great, and we'll get into some of that. I'd like to start with, you started work on electrification, right? And later built and exited generation and storage businesses. I guess, like, what drove your personal shift from generation through to the gap that you're facing and tackling now at Relode?
Okay, so I mean, I've been in the electrical engineering and electrification space since the beginning of my career. I'm a metallurgist, but very much had a focus on the electrical side of things. And actually, I started my career in building buildings, as it were, be it data centers, and then I switched my kind of allegiance from built environment into by the way of tunnels for the London Olympics back in 2006, 2007. So I really was a baptism of fire. My career then took me into generation and specifically the battery space. We had a company called Pivot Power, and we were the first company, I think, to generate onto the transmission system via tertiary connections. So they really were a gateway into the transmission system. We since went on to build with EDF renewable support in the UK connections that weren't just tertiaries; they went via grid parks, etc. So we're a kind of a tested team. But we never want to be kind of an also-ran. We very much want to be leading the pack, as it were, like we were with batteries back in 2018, 2019. We looked around at the kind of the landscape of what was going to be coming online and would need some support from a quality team is how we came up with our demand side mandate. And so, yeah, we're looking at who's going to be using lots of power over the next 10 years that aren't really using any now or are using kind of an order of magnitude less than they will be in the future. That really was our catalyst for coming together, and it is part of the team that was Pivot Power that formed this company. So we wrote our own mandate to make sure we're in the right place for new types of customers that would probably struggle if they operated just by themselves onto very large distribution or transmission connections.
That's quite, it's like, was it running to where the ball's going to be? It's not a kind of new market forming and trying to anticipate the future needs and demand of what's coming. But I guess the flip side of that, as with anything in the grid, you've got to think about the structural constraints. What are the bigger constraints that you see coming in the GB energy system over the next decade that are going to shape the way your work or that work happens?
Well, I mean, the huge topic at the moment is obviously access to grid, and I think that will continue. There's only so fast, mainly from a resource and kind of people availability to build endless bays onto the transmission system or the kind of high voltage distribution grid. So I think there will always be some frustration for customers trying to connect. I mean, if you speak to a customer that isn't au fait with the electricity industry, they'll be horrified at getting a connection date in 10 years' time. So really what we're trying to do is make sure that we are applying for the right size connections now with a kind of a really enough headroom to really be able to give people flexibility and scalability when they come to us as a one-stop shop. So they'll be able to get access to power. They'll be able to potentially get access to a kind of growth contract where they can increase their capacity over time, but they can still have full competition of supply. So they can still appoint their own supplier, but we really handle multiple customers onto the same piece of grid infrastructure.
And yeah, that's really interesting. And for those that are maybe less familiar, like what advantages does the transmission connection versus the more traditional distribution connection like give you? Like why one over the other?
So I think people try and complicate it. I think they're one and the same thing. From an electrical characteristic point of view, they both supply electricity to you, and it really is down to your need case. So I think we've migrated off the distribution onto transmission originally because it was less congested. The DNOs were taking the flak from every single solar and onshore wind developer, and they were really busy all the way through from kind of 2010 onwards. We migrated up to transmission because we were looking for access to grid and getting the best dates originally when it came to batteries. What we're doing now is we're going up to a scale where most of our sites are kind of within reaching distance of a gigawatt for a connection. And therefore, the natural place for it is the transmission system. And actually, there's a lot of issues about getting timely connections at the moment. And part of that is possibly due to the wrong type of size or magnitude of connections going onto the transmission system. Possibly there should be some redistribution. If you're putting a 100 or 200 megawatt connection onto a bay that's capable of 1.5, 1.6 gigawatts, we're not really utilizing the assets the best we can in the UK. So, I mean, that's probably too big a topic for now, and it's probably one the industry should be addressing. I think for us, the key thing is to get access to timely power at the scale we need for kind of multiple customers.
That's a really interesting angle because, yeah, I've not really thought about it that way round, but you are almost then artificially reducing the available connection capacity, right, by downsizing or not using up the full physical sort of capability of whatever asset you're using to connect.
Yeah, and it's a really difficult kind of conundrum for the amazing people running our transmission distribution systems. It's the way the codes have been written, and the CUSC was written back in really for the nuclear power station generation. That was when our code was written. It doesn't take into account the kind of problems and dilemmas we're going through now.
Yeah.
And I think it's probably a group or combined effort that we need to have to start that redistribution. But you've still got to be fair for all the developers out there and the customers out there that have spent lots of time and definitely lots of money getting into queue positions and developing land and planning to then have it totally onto a different network. So it's the art of the possible. It's definitely possible. It's whether we have capacity or willingness to have a think about it. But for me, it just makes sense if you've got a bay and a bay being a piece of physical infrastructure on a transmission system. If it's an order of magnitude underutilized, it really is a bit of a waste. Where for us, Relode, the natural position for it is the transmission system.
It's interesting because it's like I always think it's one of the best real world examples where like democratic free market kind of private enterprise crashes into something that's trying to be that way, but just has to be centrally planned.
Yes.
Yeah, that's it. You just end up with this really uncomfortable bit because it's really hard to figure the interface out and the fairness and like, yeah, okay.
It's tough. And I think that's partly why we exist, because we're trying to simplify that. We're trying to give people access to our power parks, which I'll come on and talk about a little bit, but they're simplified, kind of very simple kind of infrastructures. We connect to a transmission grid and we create our own high density network that you can come in and you can ask us for 200 megawatts, but that might grow to 600 megawatts over a 5-year period. We can accommodate those sort of things. Where if you try and do that in the more formal regulated grid environment, you'll have to keep applying for more capacity, and you're at risk of triggering reinforcement or causing yourself a headache and uncertainty of being able to upgrade. So it's a new type way of doing things that's probably been necessitated by the way the grid has been evolved over a period of the last kind of 40 or 50 years.
And I guess, yeah, so because it bumps right into like grid connections, as we talked about. And I mean, you must have some strong opinions on like how we saw the battery market evolve and queue dynamics get distorted. I mean, what about the current model and the current reforms do you think is still falling short?
So I've got to give credit to Ofgem and NESO and the transmission companies and the distribution companies. They've played a huge part. So I think the problem is it was left too long, and there was probably some lessons that went unlearned. Because if you look at the distribution companies from 2010 through to 2016, all the way through FIT, etc., and connecting large or kind of the 5 megawatt solar projects, there was huge queues across every single distribution network. And actually, there was probably a lesson that was learned by the DNOs that wasn't really absorbed by the higher voltage networks, where in 2018, think NESO or ESO at the time went from 10 connections per year up to several hundred in 2018, and that just grew and grew and grew through 2019, 2020, till we got to the stage where we had an 800 gigawatt queue for solar battery and onshore wind. And we probably should have jumped on it in 2021 or something and started this connections reform process much earlier. And we've probably let it happen a little bit, probably slightly unpredictably in the demand space with AI data centers. It seems to be a popular theme that the UK has got a lot of focus, which is great. We want to be one of the kind of key players in Europe as a data center host, developer, owner, whatever it is. But it does mean speculation comes with that, and so they're probably. I think we've learning that lesson. We've just got a lot of unpicking to do. So we're trying to make sure we're not caught up in the speculative side of things, and that's our day job at the moment, is to make sure that the sites we've developed are not, and also ran, they're very much if we build what we're planning to build, they can be hugely beneficial for UK PLC, as it were, and not just get caught up behind speculative data center developers, because we'll connect data centers, but we also want to connect e-fuels, and we want to connect freight, EHGV, and all sorts of large load customers that aren't there yet.
It's quite funny. Just today I was hearing about one of the major cloud infrastructure providers from a technical kind of like end user point of view. When you onboard a new account, you get like limits, and it's usually just like a process. You press a few buttons and tweak a few things, and you get those limits unlocked so that you can do more in your account. And for the first time, our engineers are reporting that these cloud infrastructure, the major household names that you know of, have turned and gone, yeah, there'll be a 6-month queue because we haven't got any GPU capacity on the London data center or the Dublin one or the Netherlands one, and unless you want to move your load over to this place or that place. And that's quite new and not really happened before. And I just feel like, is this an early warning sign that the bubble is popping, and actually the AI sort of workload has gone too far, and we'll start to see that scarcity appear in the data center capacity that we have, which is fairly new. That's quite a new concept, and therefore more pressure from data centers coming, more grid connection, more bandwidth. It's quite an interesting time to be monitoring that space. Everyone we've spoken to in energy is the hot topic. Now the grid reform's happening, it's like the new thing is data centers and what's it going to do and where's it going to go. I like the approach you're suggesting is like, well, yeah, it's just one of many things, and we can kind of make balance across all of it. I guess the bit I'm missing then, and some of the audience might be, so we've mentioned power parks. Give us the 101 and a bit of a deep dive. What do they actually look like, and like the commercial and the grid structures that sit behind it? How have you made all this possible?
Okay. No, I talk about it all day. I love our topic, so I'll be very happy to. Essentially, our power parks look like a substation, probably at 132,000 volts, and they will sit in a piece of land that we have taken an option on currently, and we will develop out. So ultimately, we'll take power from the transmission system. We'll take it into a modular, kind of very modern, modular and extendable substation, and it's going to be firm power. So it's going to be effectively twice the size it needs to be capacity-wise, such that if we get a tree fall over or a pylon go down on the transmission system or on our connection, we've still got 100% capacity. We think that's really important. It's always been important in the data center world, but it will be equally important for logistics companies and shipping companies to have that sort of resilience in our network. So we've got a power park that sits in a piece of land that looks like a substation. On that land, we can also host some of our customers, some of the smaller customers, be it a data center, be it a truck stop, which we may or may not develop some of our own, or be it a vertical farm, for example. But we can also host customers that are off our land. So be it if we're 5 kilometers away from a port that's developing its own e-fuel or is electrifying its dock frontage for cold ironing of ships, we can still provide that network via private wire off our site. So it becomes a really versatile piece of network. It's still built to the same standards as a regulated network, but it just offers that flexibility being private infrastructure.
Yeah, okay. I quite like that. I didn't think about the private wire piece, but it makes sense that, yeah, you're basically acting as an optimizer then of getting the most capacity out of that scarce land connection kind of resource and chopping up what's available and making it affordable to businesses of all sizes, not just like those that first come, first served.
I think, sorry to interrupt. I think the really exciting thing for me is once we have this infrastructure in place, if a customer that's just starting to think about electrification in, let's say, 2030, and if they apply it for themselves, if things are carry on like they are, it might be 2040 by the time they can actually get a connection. If they come to us, we are building capacity ready to take them, and again, ready to take them at a lower level and then suit their ambitions as they grow. So I think that's really key for us to make sure that we are hugely accessible, but probably without, say, a truck company needing to build their own grid team to submit all the compliance statements you need to be on the transmission system. All the stuff people don't think about now is our bread and butter. So we can take away 28-week reports that you need to submit every year. We can do all that compliance stuff, and people can come on and have a much bigger connection than they might want to have otherwise if they're doing it all themselves. I think the next step when you talk about commercialization is once we're connected and up and running, there's no stopping us modifying our solution and start taking renewables on board or taking SMRs, kind of small modular reactors on, and start really playing some tunes when it comes to how people buy their electricity, be it genuinely electrically proximate PPAs where we're all on the same network, we're all behind a transmission boundary, and actually we can start selling or our customers can start buying electricity from generation on our network and start really optimizing it. And when we're talking to some of our potential data center customers and CPOs, that's what gets exciting, because actually you can start competing with Europe by bringing down the cost of electricity. That's what gets people really excited, kind of the long-term vision and compatibility of multiple different customers.
Yeah, and I mean, you get into all the fun stuff around microgrid optimization, which is all, it's like, sounds complicated, but it's all possible and it's well studied and well done. And then, yeah, it speaks back to that. The biggest issue in all of this is that future looking talent pipeline of people that can actually do the high voltage stuff. Well, you're unpicking out a little bit and sort of maximizing what's available in a more local environment. So you've not got to put as much pressure on the transmission system for upgrades and stuff, because you're kind of holding all that in a local setup. No, I really like that. I guess, so we've mentioned truck stops and ports. You've mentioned data centers dominate the landscape. Are there other asset classes that are growing at a rate that people are maybe less aware of, or what else should we be thinking about in this domain?
Well, I think trucks are probably a little bit underplayed in the UK. Like electrification of the truck fleet in the UK will be game changing, not just for tailpipe emission, not just the speed lorries go up hills, because they're kind of constrained by quite traditional diesel engines. Once you electrify trucks, you have to start thinking about actually there's 500,000 trucks on the road.
Not just in the UK, yeah.
Just in the UK, so just under 500,000 trucks in the UK, most of which will charge overnight and be able to do some or all of their journeys on that battery charge. But actually, a lot of them that either tramp around the UK or do very specific routes will need to charge up mid-route. And the new standard for those is over a megawatt per vehicle. If you start looking at the kind of the golden routes where you might have a port or you might have a local distribution center, and then the other end is a central distribution center, and they're doing 2 of these runs a day, they're clocking up hundreds of miles, but they're forced to stop every 4.5 hours for 45 minutes. So there's natural charging opportunities, and you can start sizing batteries correctly so you're not carrying too much weight. But if we can charge kind of several hundred kilowatt hours of battery on a truck in 30 minutes, you start opening up loads of opportunities. And so that's really what we're talking about. But we might need 100 bays all charging at a megawatt. You immediately into 100 megawatts, which is bigger than anything we're talking about. And we've kind of shown it on the picture behind my head at the moment, where we really see this as a big problem if we don't address it now, because it will catch us up. ICE trucks or diesel trucks can't be sold in Europe, and all the truck manufacturers, bar some really interesting UK companies, come from Europe, and they will have to sell only electric vehicles from 2035, and they'll be heavily penalized going forwards if proportions of their fleet aren't electric. So it's going to happen to us one way or another, and we need to be ready, but we need to be ready at scale. We don't want chicken and egg. I don't like that term, and we don't want to have this kind of public perception like we did with domestic vehicles, where people moan about infrastructure and they moan about cost of cars. These are fleet managed vehicles that are going to come at scale, and we need to be ready for them as a country. So we want to be part of that solution, and we put our connections and take land where we think they're going to be most valuable. So that's a big one that people probably don't think about immediately. They think about a few megawatts here and there. It's not. It's going to be huge. There's also things like we mentioned ports, and just plugging in a ship is a multi-megawatt kind of electrical requirement. Once you get up to cruise ships, there might be 10 or 15 megawatts just to run the air conditioning and the house supplies. If you look at Southampton Port, they can have 3 cruise ships in ready for a Friday night departure. Just the emissions from those ships currently running megawatts of diesel engines in port is horrible, but we need to get power to these ports. It's very, very difficult. If you then step up a level from there and look at the huge potential we have in the UK, given all the renewables we have for e-fuels, be it e-methanol or ammonia, they all require massive amounts of power if we're going to do it green. And so we're making sure, again, we're in the right parts of the country for that. We're better transporting the energy via electricity. We've got loads of electrical infrastructure. Let's get it to the right place and then make the fuel trying to transport liquid or volatile compounds around via our road network or via a new pipe network. So we think they're the major categories. You've also got some really interesting vertical farming coming into play that might be 10 or 15 megawatts per pod, which again is the size of a small town on a single vertical farm pod. So there's loads of things that we just don't have now that we will want in 10 years' time. And it's for people like us, I think, to come up with novel but robust and solutions, but using mature technology.
I think it's really interesting as well, because they're all fascinating use cases that are definitely coming at scale, but they're all a lot more managed than like the electrification of domestic vehicles, right? And so like my head was when you were talking about big fleets of HGVs, like 500,000. So you got 500 gigawatts of like batteries basically roaming around the roads. And it begs the question that when we get vehicle to grid sussed out, you've got quite a lot of incentive to go down the virtual power plant, especially if you've got 4 stopping points. I mean, as if we've not got fully autonomous trucks by that point. But I think it's it's interesting. You get into some interesting numbers really, really quickly where secondary, all of those add up to really good secondary storage capacity, secondary demand and load, like movement around in the grid, where you can do a lot of clever stuff to actually reap even more of the benefits of investing in this kind of infrastructure if we can get there with it. But yeah, port upgrades and the like they're not small projects to undertake.
They're not small. They're very established companies that run these entities. They're amazing at what they do, but actually electrification is quite new to everyone at this scale. And I mean, I haven't even talked about some of the grid stability services you can plug onto our networks, and the cost of storage is coming down. The learning curve is phenomenal. And actually, when you look to some of the really high the areas in America like Virginia that are really advanced from a data center point of view, actually the grid needs a bit more help than just a big connection. The way kind of NVIDIA chips are learning AI content using their large language models is really difficult to manage for the grid. So we're potentially going to need long duration storage of some flavor on these networks to support the application of some of the big hyperscale data centers. So it's going to be fascinating. And yeah, our whole objective is just to be at the right place at the right time, both to support them, but also to kind of back ourselves to make sure we're providing good infrastructure for the right people at the right time.
No, really cool. And I guess, so we've touched on AI a little bit. Where do you see a room for AI helping in the work that you do and in accelerating this kind of transition, the digitalization or the use of data, or where are the constraints still just like capital, land, access?
So look, the things we do require a degree of patient capital, but there's some savvy investors out there, and we're obviously continue to talk to them. We continue to raise money to do this, and we've had amazing support from our investors. When it comes to AI, I think the strongest case is part of the planning. Some of the planning documents and the submissions we have to make are phenomenally huge. And actually, if local authorities are going to start implementing those things, which we're hearing about, and we're hearing about National Grid and DSO starting to use AI to assess applications and to verify some of our submissions, then actually that's positive. Whether it's a deep kind of implementation of AI or whether it's just a kind of a process layer, I don't think it matters. I think if we can help get efficient connections and improve the commerciality of what we're doing and what others are doing, then I think that's positive. I think the general uptake of AI, however, is exceeding even my quite ambitious kind of expectations. Just the amount of people using it in the investment kind of area is blowing my mind.
Well, I mean, I didn't even have to pay you to say that, but yeah, it should come at no surprise that we've seen the same thing, like the project development, planning, the finance part of this game. It's a wonderful use case for the application of AI. We're building the Hypercube platform now, which is looking at exactly that. How do you submit tenders supported by really rigorous AI rubrics and scoring frameworks? How do you evaluate RFPs that you've put out, perhaps? How do you do project risk? We've built a number of kind of multi-agent systems that do exactly this. So if anyone is bumping into those headaches, please give us a shout. But it's still early days and no one's solved the problem yet. I think you're right that everyone centrally is talking about it and they're moving on it, but how deep and how useful, and like no one wants to be the first. It's a fascinating place to play. And I guess my question is, like, 10 years from now, what does success look like, do you think, for like us as a country, this is a system?
Well, I think when it comes to AI and kind of the planning and financing, etc., I think the key thing to do is not just generate more and more documents that we then need another AI solution to read more and more documents. I think the key thing is to compact these things and make the processes more streamlined. I think if we can point them in that direction rather than just copying human behavior, where we write a report for the report's sake, if we're left to these kind of current hierarchies. So I think if we can have the focus condensing and streamlining processes, then I think that's a massive win. I think if we just make things bigger because we can, I think that would be a real shame. And I think broadly backing projects that add the most for GB and for country and for Europe and kind of mankind generally. I think that's the win. If we're having projects for project's sake, or we're spending taxpayers' money on projects that are either already mature and don't need support, but just because they're an easy win, I think that's when people start to lose a little bit of faith. So I think if we see good projects getting support, or just getting the kind of glide path to actually do what they can do without government support, I mean, they're all wins for me.
Very cool. Yeah, I'm excited. I mean, there's a lot of change coming. There'll be winners and losers, but it will definitely be fun to find out how the game gets played. I guess just last couple of questions from me. Any controversial opinions or hot takes, or heard it here first, that you could share?
I think we're grinding this out at the moment. So, but what I do think, and I've said it before publicly, I think once things like electric trucks start getting rolled out, we're going to realize there's really material benefits of them. They accelerate up hills better. They're better for drivers in terms of comfort, in terms of how they can be adopted into fleets, etc. The ability to start trading electricity rather than trading diesel, which is quite a straightforward hedge once you get into the optimization of fleets, etc. I think the opportunity so outweighs kind of the costs that people are facing. There's a lot of, what's the diesel parity price at the moment? Actually, once you get past that and you realize actually it's a no-brainer, then the optimization potential is huge, and we will need machine learning and AI and all sorts of things to really optimize power prices. But I think for me, if I'm going to call anything out, it's AI data centers are a cert. They're going to happen. The question is how much sovereign kind of machine learning, etc., will be in the country. I think for me, it's the potential for really leading the world in electrifying our fleets and then optimizing them for price. I think that for me is going to be beyond people's expectations and happen quicker than most people are predicting.
Look, before we let anyone leave, I always like to ask if there's anything you'd like to promote, or if anyone in the audience would like to find out more about you or about Relode, where should we point them?
Definitely have a look at our website, www.relode.energy, and you'll find me on LinkedIn. I'm reasonably easy to get to, or just use the links on our website, or come and find me at a conference. We're out and about the whole time. Very easy to get hold of.
Okay, well, look, Mikey, this has been a great conversation. I wish you all the best, and I look forward to seeing what Relode get up to over the next few years.
Thank you ever so much. Thank you for the invite. I really look forward to whatever Hypercube are doing at the moment. Some fantastic guests, so glad to be part of it.
Thank you once again for listening to the Hypercube Energy Podcast. As always, if you have any feedback or comments, or you want to get involved, please get in touch. And if you want to find out more about what's happening in data and AI across the energy sector, please join the Beyond Energy community. And I look forward to speaking to you soon.